Hi everyone, I'm Deborah De Rosa. This is my presentation titled Communicating Quantum Mechanics, a Phenomenological Approach. Quantum mechanics represents a paradigmatic case of a highly predictive and technically well-established scientific theory that is conceptually problematic. Unlike other physical theories, it exhibits a marked gap between predictive success and conceptual intelligibility. This gap is evident both in specialist debates, as indicated by the plurality of competing interpretations, and in communication with non-expert audiences. Despite its experimental and technological success, the ontological and epistemological significance of quantum mechanics remains controversial. Competing interpretations, including Copenhagen, many worlds, Bohmian, Cubism, and relational approaches, highlight that the conflict concerns not the efficacy of the mathematical formalism, but the difficulty of articulating a conceptual framework adequate to the phenomena described by the theory. The interpretive question is therefore not about the correctness of the theory, but about the possibility of communicating its meaning to render intelligible why the quantum formalism works, which reality it describes, and what image of the world it implies. The interpretive challenges of quantum mechanics partly stem from the use of conceptual categories inherited from classical physics, where objects are assumed to have well-defined properties independent of observation. Propositions about these properties are simultaneously decidable, and Boolean logic provides an adequate description of physical reality. Quantum theory challenges these assumptions. In particular, a quantum state can be maximal, meaning it cannot be further refined without contradiction, yet not complete. It may fail to determine all properties of a system. Some properties may be defined and measurable in a given experimental context, but remain indeterminate in another. This context dependence introduces a break with the classical view that properties exist absolutely and independently of observation. This contribution argues that Husserlian phenomenology can provide theoretical tools for constructing meaning in the interpretation of quantum mechanics. The goal is not to explain the theory physically via phenomenology, but to show that phenomenological categories such as givenness, perspective variation, horizon, and constitution offer a conceptual language particularly suited to the non-classical features of quantum phenomena: contextuality, state incompleteness, indeterminacy, and measurement-dependent outcomes. The objective is to address the interpretive problem philosophically, demonstrating that phenomenology offers conceptual and methodological resources to construct and communicate the sense of quantum phenomena, also to expand the conceptual vocabulary needed to interpret, discuss, and share the results of the theory. Husserlian phenomenology provides a sophisticated theory of the constitution of meanings and the givenness of phenomena. Meanings are not objective properties independent of experience, but emerge through acts of constitution shareable among subjects. Several concepts are particularly relevant to quantum mechanics. Profiles. Objects never appear in their totality. Every observation captures only certain aspects of a phenomenon, leaving unactualized potentialities implicit. Horizon of possibilities. Every perceptual or observational act implies a network of possibilities beyond what is actually given, forming a broader context of meaning. And then constitution, objectivity arises not from independent reality, but from acts of perception and cognition that generate intersubjectively recognizable structures of meanings. Categorical intuition. Consciousness can constitute ideal meanings that organize experience beyond immediate sensory input, allowing understanding of relations and properties not automatically emergent from empirical observation. Phenomenological categories provide a conceptual vocabulary for describing quantum phenomena. Partiality and profiles. A quantum state does not assign definite values to all observables simultaneously. This reflects non-actualized potentialities rather than ontological deficiency. Contextuality. Measurement actualizes a profile within the possibilities already structured in the state. Outcomes depend on experimental configuration, analogous to how an object appears under different perceptual perspectives. Intersubjective objectivity. Measurement is constitutive of manifestation but always shareable. Reality does not require a metaphysically privileged observer. This framework allows replacing misleading metaphors like the magical collapse with a current conception of actuality and potentiality. Phenomenology does not explain quantum physics, nor could it claim to replace it. Its contribution, in our view, could consist in providing the conceptual categories necessary to understand what quantum physical phenomena mean, avoiding both popularized mythification and the entrapment in concepts inherited from classical physics. The counterintuitive character of quantum mechanics arises from attempting to interpret non-classical phenomena using classical concepts. Phenomenology, through analysis of givenness and the constitution of meaning, provides a language suited to the mode of appearance of quantum phenomena. Well, this is not phenomenologizing physics, but recognizing that an innovative theory demands an equally innovative conceptual apparatus. Phenomenology contributes by making sayable what physics discovers, allowing rigorous communication of meaning. If the aim of interpreting quantum mechanics is to understand not only how the theory works, but the meaning of the world it reveals, phenomenology offers a rigorous and fertile path. Where interpretations today require a reconstruction of sense rather than new formulas, phenomenology can provide a philosophically rigorous and fruitful contribution to their evolution.